Hey folks, Mr. Dell here. We are looking at a problem where we have a situation where we're determining whether it is a linear or non-linear growth. So given a situation, is it linear or is it non-linear? That's what we're wanting to look for. So let's start off here. We've got this problem is a CPM problem, and it is from CC3. So course 3, CPM, and this is section 9.1.3. All right, so that's what we have. Let me adjust my camera a little bit, get a little higher so we can see what I'm working on. Here we go. So let's read it and we'll go from there. So it says Martha is saving money to buy a new laptop computer that costs $1,800. She received $200 for her birthday and has a job where she makes $150 each week. So it wants us to make a table and a graph for this situation. So I'll start with the table. So we're going to talk about money earned or money saved. How about that? Money saved or earned, either way you can put it. When she's earning, she's saving. And number of weeks. I'm going to put my number of weeks over here. Okay. So number of weeks, because normally my time is my independent variable, my X variable. So I'm going to put it in that column that we normally would have X. So we start off, she received $200 for her birthday. So that would be starting at 0, right? That's starting at 0. She has $200, right? Because then we go from there and it says that we're getting $150 each week. So then on week 1, she gets $150 more. So that becomes $350. And then week 2, she gets another $150. So $150 on top of that is $500. Week 3, another $150 makes that $650. Week 4, another $150 makes that $800. Right? Week 5, another $150, we have $950. And week 6, another $150, we have that makes that $1,100. Then week 7, we're looking at $1,250, adding $150 to it. Week 8 gives us another $150, makes that $1,400. Week 9 makes that $1,550. Week 10, we're at $1,700. And then week 11 is when we break that 1,800, and we're at now 1,850. So there's the table. So it gives us that breakdown to say it's going to take 11 weeks for her to get to that amount that she wants to buy the car, right? Or excuse me, buy the laptop, not the car, buy the laptop. So there's our table. So then it wants us to also make a graph. So what does a graph look for the situation? So we're graph, we know we're dealing with just positives. And my situation on my graph, I'm going to therefore draw a positive coordinate quadrant, right? The positive quadrant, quadrant 1. My weeks, I'm going to put on my x-axis because that is my independent variable, and it's going by ones. So that's 1, 2, 3, 4, 5, and so on and so forth. My y-axis, I'll go by hundreds is what I'm going to do. So this is 0. So this is 100, 200, 300, and so on and so forth. 400. So let's see, that'd be 500. So 6, 7, 8, 9, 10. So 1,000. 1, 2, 3, 4, 5, 1,500. So there's my graph. And if I'm graphing this, we started at 200 in week 0, right? Week 0 in the beginning, 200. And then week 1 was adding 150. So it would end up there. Week 2 was adding another 150. So we're at 500. Week 3, another 150. Week 4, another 150. And week 5, another 150. Notice I'm going up. I'm actually going up a full grid, which is 100, plus a half a grid, which is 50. So here I can go half a grid, which is a 50, plus a full grid, which is another 100. So I can see really right away that I'm dealing with a linear situation. And in fact, with this problem, though, I don't necessarily, I'm not going to create a solid line because it says that she's getting 150 each week. So that would be a discrete situation. So how do we determine how we show discrete is if we wanted to show the pattern, we can show the pattern using a dashed line with a discrete situation. Okay. So there's my graph. So, I didn't label this side. This slide is money saved, and that's my weeks. Okay. So there's my graph. There's my table. So then it asks us to explain how you can use the table or graph to predict how many weeks it'll take Martha to earn money, enough money to pay for a new computer. So with the table, we can just continue the table. So to answer that question, we did it. We continued the table until we ended up with the 1,800 or more on the money saved. So the table, we just continue the pattern. So is what we're going to say in this question really is continue the pattern for the table. And then for part B as well, for the graph, we can follow the line, the pattern to find where it becomes 1,800. I didn't pull my graph down enough, but yeah, what you'd want to do is have your graph be far enough down, or I should have went by 150 each marking, but that's okay. So that's what we would say for B is continue the pattern of the table or follow the trend line for the graph. Continue the pattern for the table or follow the trend line for the graph. And then part C, explain how you can tell from both the table and graph whether this example is linear or non-linear. So from the table, how do we tell it's linear is there's a constant rate of change. It's always adding 150 every time. So it's a constant rate of change in the table. It's adding 150 each time as the weeks go up by 1. So as the weeks go up by 1 every time, you're adding 1 to each week, the cost goes up by 150. So it's a constant rate of change in the table. And then in the graph, we see that it's also linear because the values, the points that are put on the graph are in a straight linear pattern. They connect to be a line. So we could say they connect to be a line on the graph, and then there's a constant rate of change in the table. Okay, that's how we explain C. All right, there you go.